Last time, what we had, cases 1 and 2, no? For cases 1 and 2, they have the same forms, except that they differ in condition. So, if the integrand is a combination of product of powers of sine and cosine, where at least one of m and n is a positive odd integer, so that is case 1. But if both m and n are even positive integers, then um, positive even integers, then case 2, no? So the next case, we have case 3. So we have case 3. For case 3, if the integrand takes the form integral of tangent to the nu du, or integral of cotangent to the nu du, where n is a positive integer greater than or equal to 3. Actually, you can have 2, but for 2, that's basic. That can be directly evaluated by transforming into secant squared minus 1. But if n is greater than or equal to 3, then we can use the following transformation. We have tangent squared u. You're going to transform this into secant squared u minus 1. But let's say the one that is given is in terms of cotangent to the nu. The transformation that you're going to have, cotangent squared u, and that is equal to cosecant squared u minus 1. Okay? So what's the strategy? So let us have it through examples. Let's say we're asked to evaluate number 1. We have integral of tangent cube for theta d theta. So this satisfies the form, no? So this first form, integral of tangent to the nu du, where n here, which is 3, is a positive integer, which is equal to 3, and we require greater than or equal to 3, no? So the first step is to get a quadratic tangent and then separate the remaining. So the remaining is tangent for theta, then d theta. So that quadratic, you're going to transform it into secant squared for theta minus 1. That's the identity for tangent squared. Okay, guys? Can you follow, guys? So this one. So this is what we transformed. This quadratic. You always aggregate a quadratic. And that is equal to, so distribute this tangent for theta inside, getting tangent for theta, and then secant squared will serve as the derivative of the tangent. And then minus integral of tangent of 4 theta d theta. Okay, guys? This second integral, you can evaluate that by integration of trigonometric function. Huh? So we have a formula for this. And this first part, first integral, is by general power formula. Okay, guys? So I'm going to put 4 balanced by 1/4. So this is equal to 1/4 integral of tangent theta, 4 theta I mean, raised to what? Raised to 1. And the derivative of tangent 4 theta is 4. So I put 4, I balance outside by 1/4. And then copy the rest. No? Then d theta. So in this case, second integral, I'm going to put 4 also. So tangent 4 theta. So derivative of 4 theta is 4, then times d theta. Okay? So integral of tangent u du. So what is that equal to? So for the first integral, that is equal to 1/4. So again, by general power formula, so GPF, na? So that's GPF. N is 1. So u to the n plus 1 all over n plus 1. U to the n du. For the second integral, that is equal to 1/4. What is the integral of tangent 4 theta? Diasis. Trixie. What is the integral of tangent 4 theta for d theta, tangent u du? Diasis. Tale. Serrano. Guys. What is the integral? ln what? Guys.
Cosine for theta po.
If you use cosine, you have to make it plus because it is negative ln cosine. Okay? If you use secant, so we have, you retain the sign negative. So ln secant of 4 theta. Okay, guys? But if you use cosine, so negative ln cosine of 4 theta, absolute value of that. So this will change in sign, plus, because negative, negative. Okay? So this is equal to 1 over 8 tangent squared 4 theta, and then minus 1/4 ln of secant 4 theta, and absolute value of that plus c. Okay? Do you have any question with that? Okay, so let's have number 2. So given the integral of cotangent to the fourth, then let's say x squared cotangent to the fourth 2x cubed dx. So this takes the form of cotangent to the n. Our u is 2x cubed, and the derivative of 2x cubed is 6x squared. So only constant is the problem, no? For the derivative of this argument. So by transformation, first step is to get a quadratic out of cotangent to the fourth. One quadratic, cotangent squared 2x cubed, and we're going to segregate the remaining. And it so happens that it is also a quadratic, but you're not going to transform the one that you're going to segregate, okay? And then times x squared dx. This x squared dx is part of the differential later of the argument, no? So what are we going to transform? This quadratic that we segregated. So this one, transform that. And what is the transformation, guys? Cosecant squared. So what is the argument? Two x cubed. Then minus 1, okay? Multiplied by cotangent or squared of 2x cubed times x squared dx. And this is equal to, so let's distribute. Cosecant squared times cotangent squared. So that is cotangent squared of 2x cubed cosecant squared times x squared. So we have x squared cosecant squared of 2x cubed dx minus, distribute this to 1, but minus. So we have integral of cotangent squared of 2x cubed times x squared dx. Okay? Now, so what is missing here? Our u is cotangent. So by this time, you should know how to do it mentally, huh? So what is our u here? Cotangent. And then what's the derivative of cotangent? Negative. Cosecant squared, derivative of 2x cubed, 6x squared. So we need negative 6. So balance by negative 1 over 6. And then we can do it by general power formula for integration. So again, I will put negative 6, then copy x squared, cosecant squared, 2x cubed dx. No? Okay. So this is now integral of u to the n du minus, this again satisfies case 3, cotangent to the n. No? So actually, ready for transformation. That is cosecant squared 2x cubed minus 1 dx. Okay? So, again, this is u to the n. This is u to the n. This is our du. So, getting 1 over 6 times u to the n plus 1 over n plus 1, then minus, this is what? Sorry, I think I forgot to copy. You're not, you know, I think you're not really all ears, guys, because you're not a help when every time I miss something. So here, I miss what? When I distribute this to 1, must have x squared here. So this is x squared dx. That one, because this is what I transformed. So minus integral of cosecant squared 2x cubed times this x squared. And then negative, negative, that is positive. Integral of x cubed. I mean x squared. Okay? Hi guys, still alive?
Yes
Yes
po.
po, sir.
1 over 18. So negative 1 over 18 cotangent cubed of 2x cubed minus, what is the integral of cosecant squared u? We need to put 6 here because this, if this is u, the derivative is 6x squared multiplied by dx to be its du. And then balanced by 1 over 6. So 1 over 6, what is the integral of cosecant squared u du, guys? Negative. So now positive cotangent of u. Okay? So that's basic, no? Plus u to the n plus 1. This is simple power. So x cubed over 3 plus c. Okay? Please check if I miss something, guys. Okay, so do you have question with that, guys? Okay, so number 3. Integral of tangent to the fifth is square root of x dx over square root of x. What about this, guys? Does it satisfy the form, guys? Yes, no?
Yes, sir.
Okay, so our n here is 5, okay? So again, what is the first step? You segregate a quadratic, which later we're going to transform, and then the rest, so will be segregated. So we have tangent cubed is square root of x times, later we have dx over is square root of x part of the differential. Mm. And this is equal to, what's next, guys? Transform, that is secant
Square.
square root of x minus 1, no? Then tangent cubed is square root of x times dx over is square root of x. So we're going to distribute now. Tangent cubed times secant squared, getting tangent cubed is square root of x times, if our u is tangent, the differential is this, no? Secant squared is square root of x over is square root of x and dx. All we have to do later, fix the constant that in case will be missing. So if my u is tangent is square root of x, what is my du here? My du is 1 over 2 is square root of x, which is the derivative of this, no? Radical. You have to put 2 here. And derivative of tangent secant squared is square root of x. Okay? And then balance by 2 outside later, no? For the second integral, we have integral of tangent cubed is square root of x times dx over square root of x. And this is again case 3 with n equals 3. So I will put 2 outside because I am planning to introduce 1/2 inside. Over 2 is square root of x. And then here, transform by segregating tangent is squared is square root of x times, there is a remaining tangent times dx over square root of x. Actually, this second integral is like our example number 1, no? That the only difference is the argument. So we have 2 times u to the n plus 1, u to the n plus 1, and this is du. So again, this is u to the n, u to the n, and this is the du. So u to the n plus 1 over n plus 1 minus, what about this second integral? So transform that. So we have secant squared is square root of x minus 1. Don't be surprised if we keep on transforming, huh? Because that's the title. As long as the condition in the form is satisfied, you keep on transforming. Okay? So this is equal to 1/4 times 2 is 1/2. 1/2 tangent to the fourth square root of x minus distribute integral of tangent square root of x times secant squared square root of x over square root of x, then multiply by 2 that denominator here to complete the differential of tangent square root of x. Then multiply outside by 2. Okay, guys? Minus, minus, plus. So, integral of tangent is square root of x times dx over square root of x. If my u here in tangent is square root of x, my du is 1 over 2 square root of x dx. So I have to put 2 balanced by 2 outside. Get that, guys?
Yes.
Guys, what is the first term? Copy. Tangent to the fourth, 1/2 tangent to the fourth square root of x. Then second one, integral of minus 2 times integral of u to the n du. So this is now u to the n plus 1 over n plus 1, then plus times 2, no? So that is times 2. Again, let me rewrite that. 2 minus 2 times u to the n plus 1 over n plus 1. Then for the third integral, so again, integral of tangent u du. What's the answer? ln of the absolute value of secant is square root of x plus what? Plus c. Clear, guys? Guys, got it? Did you get that? Tangent to the fourth square root of x minus tangent squared square root of x. So again, 1/2 tangent to the fourth square root of x minus tangent squared square root of x because 2 is cancelled out plus 2 ln of secant square root of x. Absolute value of that secant plus c. Okay? A question, guys? Any question with that, guys?
Wala pa naman po.
Wala. Were you able to do your activity?
Hindi pa po tapos.
Naka. Okay, so let's now have the last one here. Number 4. Integral of cotangent to the 6 3 ln of x over x dx. So what about this? So what's the first step, guys? So this takes the form of integral of cotangent to the n, no? U du. So, first step, segregate a quadratic cotangent. The argument is 3 ln x. The remaining is, we have cotangent to the fourth, no? Times 1 over x, then dx. So, 1 over x, cotangent to the fourth of 3 ln x dx. And that is equal to, let's transform cotangent squared, that quadratic that we segregated from the rest. So, giving cosecant squared of 3 ln x then minus 1, then multiplied by this, no? Let's just copy this. Okay? Yan. Let's distribute. And that is equal to integral of cotangent to the fourth of 3 ln x times, so this is cosecant squared. Cosecant squared of 3 ln x dx over x. Okay? Yeah. Then the next, we have integral of cotangent to the fourth. So multiplied here. And this is again by transformation, times dx over x. Okay? So I'm going to put, what do I need? Cotangent to the n, u to the n. The derivative of cotangent is negative. Then derivative of its argument is 3 over x. So negative 3, I put negative 3. There is already x in the denominator. Cosecant squared, we have that already, then dx. Just balance outside by negative 1/3. So by general power formula, so 1/3 negative times u to the n plus 1 over n plus 1. Okay? So minus, so again, u to the n du by power formula. This is our u to the n, and this is our du. What about in the second one, guys? Any suggestion, guys? So we segregate cotangent squared, 3 ln x, then the remaining cotangent squared times 1 over x. Dx. Copy, negative 1 over 15. Cotangent to the fifth of 3 ln x minus, this is by transformation. Cosecant squared of 3 ln x, okay, minus 1 times this quantity. Let's copy. Yan. Okay? How can you follow, guys?
Yes po, sir.
Negative 1 over 15, cotangent to the fifth, then 3 ln of x minus. Distribute. Integral of cotangent squared of 3 ln x times 1 over x times cosecant squared. Cotangent times cosecant. I'm going to put here the cosecant squared because that is the derivative of cotangent. So cosecant squared, then 3 ln x. Actually, we did this already, no? All we have to do is to have the constant needed. So that's the only difference before. So I will put negative derivative of cotangent 3 ln x is negative 3 cosecant squared ln of 3 ln x over x. Then balanced by negative 1/3. And it is now positive. Okay? Why did it become positive, guys? Because I put negative 3 balanced by negative 1/3. It is now positive. And then distribute negative, negative, positive, integral. So that's the last, no? So, but that is cotangent squared. I can transform that into, so again, this is to be distributed here, but I'm going to transform that into cosecant squared of 3 ln x minus 1 quantity dx over x. Okay? Guys, I did not write any more cotangent squared. I transformed that immediately. As you become familiar, you can skip some steps. So we now have negative 1 over 15 cotangent to the fifth times 3 ln x plus u to the n, integral of this is u to the n plus 1. So times 1/3, u to the n plus 1. What is that? U to the third, no? Of 3 ln x all over 3. And then plus, here, cosecant squared. What is the integral? I will put 3. I need 3. So, again, plus integral of cosecant squared of ln x again plus integral of cosecant squared of 3 ln x. Yan, distribute this here. Distribute. That is times dx over x. Okay, guys? But I have to put 3 because the derivative of 3 ln x is 3 over x. But I have to balance outside by 3 since there is no 3 originally. And the next, distribute. So we get what? Minus integral of dx over x. Guys, still alive, guys?
Yes po.
Yes,
Nako.
sir.
You are going to do that also. Remember, there are 6 cases all in all that we're going to have. Okay? So I'll be copying this last line because I will be moving to the next slide. And let's copy this on the next slide. Okay? Okay. So this is equal to negative 1 over 15 cotangent to the fifth of 3 ln x, then plus 1 over 9 cotangent cubed of 3 ln x, plus, what is the integral of cosecant squared u du? Cosecant squared u du. Negative cotangent of u. May u is 3 ln x. Times 1/3. And then the last one, integral of dx over x. What is the integral of dx over x, guys? Guys. Guys. Nako, ayan, mga mute na. Plus C. Dominic, do I need Dominic T? Ay, Mr. T. Hindi ko pa naririnig magsalita pa si Mr. T. Pag sasagutan ay sumagot. O, Domingo. Do I need to put absolute value? Domingo? Domingo?
Yes po, sir.
No need. Why no need? Because originally, there is already a presence of ln x. So it is implied already that you cannot substitute negative value. So it is carried here. Since there is ln x in the given originally, so it is understood that x is never negative. And actually, even 0 not allowed. So no need for absolute value. Okay, guys? Guys.
Opo.
Okay po,
So
sir.
we're done with case 3. So we are now on case 4. Oh, what is said about case 4? Yeah. If the integral takes the form, I think I have wrong spelling here. I think before, if the integral, not the integrand. Let's erase that. If the integral, because that is the integral. Yan. Okay, guys? This is integral, not integrand. Because this is integral. If the integral takes the form actually generalization of case 3. Integral of why too thick? It's too thick. Okay. Tangent to the mu secant to the nu du, that combination, powers of tangent and secant, no? Then product of them. Or if the combination tangent cotangent, I mean tangent cotangent cosecant, no? So we have this form. Integral of cotangent to the mu cosecant to the nu du. Okay, guys? What's the condition? Where I'm going to place the condition in the n, okay? So in the n here, meaning this is what we're going to transform the secant to the n after we segregate something. So I'll be showing to you how, no? After. So where n is a positive even integer, if n is 2, so no problem anymore. This is secant squared, which is the differential already. Secant squared u du, differential already a tangent to them. So we're going to have the condition positive integer greater than or equal to 4. We start with 4 because if 2, no problem anymore. Okay, guys? So let us have this particular example. Okay, number 1, we have integral of tangent to the fifth 2 beta secant squared. I mean secant to the fourth 2 beta d beta. So my n here is what? My n is 4. It satisfies the condition. Huh? Is there a condition for the exponent of of tangent? No. Okay? So, even there is no tangent, there is tangent there, it's all right. What is important, n is even. There is presence of secant. M here can be any. Actually, m can be 3 halves, can be any number, any real number. But for n, be sure it is even. Positive greater than or equal to 4. So what we do, we are going to express this as what? As quadratic powers. As a quadratic power of secant. So, but you have to segregate secant squared. You segregate secant squared, and then the remaining express as quadratic power. So I will get secant squared 2 beta. Then we have secant squared 2 beta. Actually, what I segregated this quadratic. And it so happens that the remaining is quadratic raised to a certain power 1. So this is quadratic power. We have to have a quadratic power, then secant squared, which will serve later as the differential of the tangent, this part. Okay? So this part, we are not going to transform this. This will serve as what? This will serve as differential later of the tangent. And this is what we're going to transform. This quadratic power, and it so happens that the exponent is just 1 for the quadratic, no? So this is to be transformed. Okay? But I think I forgot the transformation that we're going to have. What is the suggestion? I'll be putting this in the next slide. So this is the suggested. Then use what? Use so this is what you're going to use. For tangent to the mu, secant to the nu du, for that integral of this, so this is the transformation that you're going to have. Secant squared u is equal to 1 plus tangent squared u. And for this combination, cotangent to the mu, cosecant to the nu du, again, integral of that, cotangent to the mu, cosecant to the nu du, this transformation, cosecant squared u is equal to 1 plus cotangent to the cotangent squared, no? U. Okay? Let's have this. That is case 4. The example I transferred in the next slide here. Okay, so what is this equal to, guys? Integral of. So this is again to be transformed, no? Tangent to the fifth retained. What we transform? Secant squared. That is 1 plus tangent squared. Then the argument is 2 beta. Then copy what we segregated. Secant squared 2 beta d beta. Next, guys. Secant squared multiplied by 2 tangent to the fifth 2 beta times 1. Here, distribute this to tangent to the fifth and secant squared inside this, no? So the first integral that we're going to have tangent to the fifth, which will serve as our u to the n, and then times secant squared 2 beta, but the derivative of 2 beta is what? Is 2. So I have to put 2 balanced by 1/2. U to the n du. U to the n du. Then plus integral of, so this secant squared times tangent. So we have tangent squared 2 beta. So similar here, but the exponent is 2. That's the difference in the first integral. So we have secant squared 2 beta d beta times what? Times 2 here. Balance y 1/2. O anyone? Guys, Gonzalez. What's the integral? Gonzalez. Conti. Chua Poco. Nako, wala na akong kausap. U to the n du. U to the n plus 1 all over n plus 1. Oy, bakit ba pag tinatanong kayo para kayo nako-COVID? U to the n du. U to the n du. What is the integral? U to the n plus 1 over n plus 1 plus c. That's it. Just multiply this constant. 1 over 12 tangent to the 6 2 beta plus 1 over 6 tangent cubed 2 beta plus c. Any question, guys? My question, may answer. Guys?
Wala pong question, sir.
Because if you are not going to reply or to my question, better that I'll just have pre-recording and just listen. Let's have number 2. Integral of square root of cotangent x. Then cosecant to the 6th x dx. Does it satisfy the form? Yes, no? And here is 6. Even, positive, even greater than 4. And actually, it's 6, no? Okay, first step, I'm going to segregate a quadratic cosecant that will serve as part of the differential later, and then the remaining should be expressed as quadratic power. This is cotangent x raised to 1/2. That function, not the x is raised, the cotangent is raised to 1/2. We have to form a quadratic, yan, power. Let's see later what we need for its exponent. Then segregate cosecant squared x, then copy dx. So this is the one that is segregated, so that later this will serve as the differential of cotangent. And this, to complete the 6, this is already cosecant squared raised to 2. So that is now a total of 6, no? So we have integral of cotangent to the 1/2 of x times, or let's transform this. And this is to be transformed until you come up with function in terms of cotangent. So this is 1 plus cotangent squared x raised to 2. Okay, guys? Let me put this here, but because I think I will be needing space.
Sir, bali po mas uunahin i-transform yung may, may exponent.
Yes, that is what is to be transformed. Yung sinegregate natin, ang sinegregate natin this part, this will serve as du later, or part of du. Will be part of du later. Okay? Differential of whatever. And then, we have to express cosecant squared in terms of cotangent, so that everything will be in terms of cotangent, and this will be the differential, or part of the differential. Okay? So this is now equal to, what is this, guys? Distribute inside, but of course we have to expand. What is the expansion? Cotangent to the 1/2 x times, what's the expansion, guys? 1 plus 2 cotangent x quantity squared, no? Cotangent squared x plus cotangent to the what? To the fourth, x. Is that correct, guys? Yung transformation, don't forget. So this is what you're going to have. Secant squared 1 plus cotangent squared. But if you have secant squared 1 plus tangent squared. And then after that, copy cosecant squared. And then distribute. So everything will be in terms of cotangent, and this will be the differential. All you have to do is to put negative, because the differential of cotangent is negative. So integral of negative, let me put the negative, because I will be needing that. I will put negative times 1 cotangent to the 1/2 Then I will put negative again, balanced by negative. So it is 2 cotangent of 2 plus 1 half, 5 halves. Am I correct, guys? Then minus again, cotangent of 4 plus 1 half, 9 halves. Is that correct, guys? And again, as I promised, I put what? Negative here because the derivative of cotangent is negative cosecant squared. So u to the n du. Every term, this is the du. Get that, guys? Guys, negative u to the n du. So what's the answer? U to the n plus 1. Or what is 2 over 2? 3 halves na of x over 3 halves. Next, we have 2 times u to the n du. So u to the n plus 1 of 5 halves plus 1, meaning plus 2 over 2, 7 halves. Check my addition, ha? Over 7 halves. And then the last one, minus u to the n. I missed the x there. U to the n.
Cotangent 11 halves po.
11 halves. So x here. Yeah. So cotangent plus 2 over 2. So 11 now. Over 2 of x. All over 11 over 2. Okay, that's it. Just simplify the numerical coefficients of each term. Negative 2/3 cotangent to the 3 halves of x minus 4/3, 4 over 7. I mean, so 4 over 7 rather. Am I right? 4 over 7? Negative, no? To the 7 halves x, and then finally 2 over 11. Cotangent to the 11 over 2 of x plus c. Okay? Question, guys?
Ba't po naging negative lahat, sir, bigla?
Kasi I put negative here sa differential. Di ba when I distribute, kung i-distribute ko itong cotangent inside, actually everything is positive. But I put negative sa differential, so everything inside becomes negative. Got it now? Do I have to change color? Ito yan eh, nagput ako ng negative here. So that's why. Yan. You see that, guys? Yan. So the reason why I put negative, negative, negative. Okay now? Guys, or if you do not want to do that, you have to do it mentally. So keep them as positive, but bearing in mind that the derivative of cotangent is negative. So you put negative in every answer. Okay now? Did I answer your question?
Okay po.
Okay. Okay, number 3. Number 3, I mean, integral of number 2 or number 3? Number 3. Integral of tangent to the fourteen x plus, times secant to the 8x dx. What about that? So again, here, what is n, guys? 8, na? So, let's say this is 7. Does it satisfy the condition? Guys?
Wait lang. Naka-cover po yung mouse yun.
Let's say yung 8 is 7. Di ba the condition is what?
Even
Positive
ng first po.
even. Di ba what's the condition?
Kailangan
Positive even. So if that is the case, it's not under this. Actually, there will be a next case. So you use this case, you consider this as case 4 if the exponent of secant or the exponent of cosecant in the other possible form or other combination. So even must be even, no? If add, not under this. Okay, so this is now equal to integral of tangent to the 14. We retain this because no problem with that anymore. Our problem is our secant. We have to transform that in terms of tangent. But since tangent has a derivative secant squared and it is available here, you segregate that. Okay? So times quadratic secant. So, but I'm going to get rid of, separate from this quadratic. So this is now just 2, no? Or 3, 3, no? 2 times 3, 6. And then that's the differential that will serve later, secant squared x, then dx, no? So secant squared will be the derivative. Of course, together with dx differential. And then we need to transform this. Okay, transform this one. So transform. Oh, you know now the transformation, right? So integral of tangent to the 14x, then 1 plus tangent squared x, quantity to the third, secant squared x, dx. And that is equal to tangent to the 14x multiplied to this. How do we cube that? That binomial in form. This is actually not binomial technically, no? So this means binomial in form only. Or this is binomial in the tangent squared. Yung 1 plus tangent squared x. So 1 plus 3 times the square of the second, the square of the first times the second, plus 3 times the first times the square of the second, plus the cube of the second to the 6th. Secant squared x dx. Secant squared will serve as the differential of every term. What's the first term? Tangent to the 14 of x. Second term, 3 times tangent to the 16 of x plus 3 times tangent to the 18 of x. And the last term, tangent to the 20, so 20th power, no, of x. Everything, so the differential of every u here, our u stand here, no, and we have different n's, 14, 16, 18, 20. All the terms together with secant squared x, the differential of the tangent, you will have power formula. U to the n plus 1, tangent to the 15, x over 15, y, u to the n du. So every term, the u is tangent, and this is the du. Plus 3 times u to the n plus 1, over n plus 1 plus 3 times u to the n plus 1 all over n plus 1. And then finally, u to the n du, u to the n plus 1. So that is u tangent to 21st of x over 21st or 21, I mean. Okay, that's it. Just write in a better form, 1 over 15 tangent to the 15 x plus 3 over 17 tangent to the 17x plus 3 over 19 tangent to the 19th x, and last one, 1 over 21 tangent to the 21st of x, plus the beautiful c. Still alive, Alcantara, Almadrigo, Behar, Chuapoco, Conti, mga napipi na kayo. Okay, guys? Yan, that's it. So we call that case what? Case 3. Okay? Anyone who can do this? Try to do this, guys. I will open the annotation. I mean, annotation ba dito, guys? Yung annotation, yung you can also write. This one, I'll be leaving this to you. Number 4, integral of, for your practice, exercises, guys. You can post in our incentive there. I'll making one. I will be having an open an open assignment for incentive so that you can post answers. Okay. So I will just open incentive so you can keep on uploading the exercises that I'm going to provide to you so that you will have additional points. You can have maximum 2 if you want. So for one problem. Okay, I have here cotangent and cotangent cube of, let's say, 3 ay, ano ba yan? 3 hyperbolic sine 2x over hyperbolic secant 2x dx. Number 2, we have integral of tangent to the fourth, 1/2 x dx. Number 3, integral of cotangent to the 9th x over sine to the 4th x dx. And number 4, we have tangent to the 6th 2x secant to the 6x dx. Okay, guys? This is supposed to be 2 also. Dapat same ang argument. Let me check. Everything is okay. Okay, you can just choose one, or if you want to solve two, it's up to you. If you want to solve everything so that you have many additional points. Okay, guys, you can do it by partner if you want. Two names, you can have it in PDF if you want. You just upload there. Do you have any question, guys, before I leave? Don't forget to have your attendance, guys, ha?
Sir, question.
Yes.
Sir, kailan niyo po post yung case 1 and 2 na PowerPoint?
In PowerPoint. Okay, I'll be posting later.
Sige po. Pati po yung discussion ngayon, sir. Post yun.
Okay.
Okay po, thank you po.
I'll be waiting for the recordings in my email. Kung minsan nalilate eh.
Sir,